Hi students, today we learn about types of sets. First one, empty set or null set. A set consisting of no element is called the empty set or null set or void set. It is denoted by empty or empty set. Okay, this is the sign for empty. Inside the set there is no element, therefore empty set. Once again, empty set means a set consisting of no element. Inside the set there is no element. Okay, take one example. The set of all integers between 1 and 2. Do you know about integers? Yes, integers means negative and positive natural numbers with 0. That is infinity, -3, -2, -1, 0, 1, 2, 3, etc. Okay, that is integers. Between 1 and 2, there is any element between 1 and 2? No. Therefore, the meaning for set of all integers between 1 and 2 is empty set. Okay. Now about singleton set. A set which has only one element is called a singleton set. Okay. Take an example. Inside the set only one element. That is, if you take A means here only one element. Of the set of all integers between 1 and 3 means you have only 2. Therefore, inside the set 2. That is also an example of singleton set. Once again, the set of all integers between 1 and 3 means in between 1 and 3 you have 2. Therefore, only one element. If you have only one element, inside the set, that is singleton set. Third, finite set. A set with finite number of elements. Finite number of elements is called a finite set. Example, if you take a set 1, 2, 3, how many elements are there? 3 elements are there. You can count how many elements inside the set. That is a finite set. Another one example, if you take A, E, I, O, U, inside the set, what are the elements? A, E, I, O, U. How many elements are there? 5 elements. You can count the elements. Therefore, finite number. Therefore, finite number of elements is called a finite set. Next, infinite set. A set which is not finite is called an infinite set. For example, if you take set of natural numbers starts from 1. But you can't say the last number. You can't count how many natural numbers are there. Therefore, not finite. Therefore, infinite set. Once again, if you take an even number, even natural numbers, therefore 2, 4, 6, etc. How many numbers are in the set? How many numbers in the set? You can't count. Okay, therefore it is not a finite set. Therefore it is an infinite set. Next, fifth one, cardinal number of a set. Okay. Cardinal number of a set means when a set is finite. Already you know about the finite set. The set is finite. The number of elements in a set is called the cardinal number of set. The cardinal number of a set, capital A, is denoted by n of A. Once again listen, the set must be finite. Finite means already you know you can count the set. Okay, that the number of elements in a set is called, it is denoted by n of A. If you take, for example, if you take one set that is 4, 6, 8. set A is equal to 2, 4, 6, 8. It is a finite set or infinite set? Yes, finite, because you can count how many elements inside the set. How many elements are there? 1, 2, 3, 4. That is denoted by n of A is equal to 4. This is the cardinal set of A. This is the cardinal set of A. A is equal to 2, 4, 6, 8. You can count 1, 2, 3, 4. Therefore, 4 elements are there. Therefore, it is a finite set. For a finite set, you can write in a cardinal number n of A is equal to 4. Here you have one example. Example 1.3. If A is equal to 1, 2, 3, 4, 5, 7, 9, 11. You have to find n of A. What is the meaning for n of A? Cardinal set of A. Okay. First write the given set. Given A is equal to 1, 2, 3, 4, 5, 7, 9, 11. Find. Is the set is finite? Yes. Here the set A is finite. Therefore, you can count. That is n of A is equal to. Count and write 1, 2, 3, 4, 5, 6, 7, 8. Therefore, your answer for n of A is equal to 8. That's all. Next, equivalent sets. Two finite sets A and B are said to be equivalent if they contain the same number of elements. It is written as A is equivalent to B. A is equivalent to B. If A and B are equivalent sets, then n of A is equal to n of B. N of A is equal to n of B. Listen, for example, you take two sets. Capital A is equal to 1, 2, 3 is equal to ABC. First, you have to find that is a finite set. Yes, A has 3 elements, B also have 3 elements. Okay. Here, set A has 3 elements. Set B has 3 elements. But the elements are not same. Here, two finite sets A and B are said to be equivalent if they contain the same number of elements. Same number of elements. Therefore, n of A is equal to 3. N of B is equal to 3. The number of elements in A and B are same. Therefore, A is equivalent to B. A is equivalent to B. Here one example 1.4 or capital P is equal to set of X such that minus 3 less than or equal to small x less than or equal to 0. Small x belongs to Z. This is in the set builder form. Capital Q is equal to set of all prime factors of 210. You have to find is this sets or equivalent sets. Capital P and Q are equivalent sets or not. Here small x belongs to Z. What is the meaning for Z? Z is a integers. Infinitive minus 3, minus 2, minus 1, 0, 1, 2, 3, infinity. Okay, in this numbers you have to take from minus 3 to 0. Less than or equal to means you must include minus 3. Less than means you not include the number minus 3. Okay, here less than or equal to, therefore you must include minus 3. Here also less than or equal to, therefore you must include 0. Therefore starts from minus 3 ends with 0. Starts from minus 3 ends with 0. Therefore, what are the elements in the set capital P? -3, -2, -1, 0. Okay. In the solution, first you write the given set. Okay. Given capital P is equal to set of x such that -3 less than or equal to x less than or equal to 0. X belongs to capital Z. Okay. The answer for this set is -3, -2, -1, 0. Therefore, -3, -2, -1, 0. Now write the second set, capital Q. The set of all prime numbers, prime factors of 2, 10. The set of all prime factors of 2, 10. The set of all prime factors of 2, 10. Prime. What do you know about prime? Prime numbers are the numbers divisible by 1 and itself. 1 and itself. Therefore, 2 is a prime number because the number divisible by 1 and 2. Okay. Example for prime numbers, 2. 2 is divisible by 1 and 2. 3. 3 is divisible by 1 and 3. 5 is divisible by 1 and 5, etc. Okay. Now, you must find the set of all prime factors of 2, 10. For that, you factorize 2, 10. Okay. See, the number ends with 0, 2, 4, 6, 8. The numbers are divisible by 2. Therefore, first you give the number 2. 1, 2 is 2. Take the next digit, that is 1. You can't give for 2 table. Therefore, you take the next digit. Before that, put 0 here. Now the number is 10. 2 5s are 10. Now, the number ends with 5. Another clue you have, that is the number ends with 0 or 5 is divisible by 5. Therefore, give the fifth table. 1, that is not enough. Take the 0. Therefore, the number is 10. 2 5s are 10. 1 5 is 5. Now, see here the number ends with 1. Therefore, it is not divisible by 2. It is not divisible by 5. Check here 21. 21 is divisible by 3. Therefore, give for 3. 3 7s are 21. Now, 7 is also a prime number. Okay. Therefore, the factors of 2, 10 are 2, 5, 3, 7. The factors of 2, 10 are 2, 5, 3, 7. Right here, 2, 5, 3, 7. Okay. Now, what you have to find? These two sets are equivalent or not. Check here. What is the condition for equivalent sets? The number of elements in the set P and Q must be same. Check the number of sets in capital P. 1, 2, 3, 4. Therefore, n of P is equal to 4 elements. Then, in the set capital Q, you have how many elements? 1, 2, 3, 4. Therefore, n of Q is equal to 4 elements. Now, see, the set P and Q have same number of elements. Therefore, capital P is equivalent to capital Q. Next set, equal sets. Two sets are said to be equal if they contain exactly the same elements. Exactly the same elements. Otherwise, they are said to be unequal. Take one example. Capital P is equal to 5, 6, 7. Capital Q is equal to 5, 6, 7. Here you have two sets with same elements, exactly same. That is 5, 6, 7. Here also 5, 6, 7. N of P is equal to N of Q. The number of elements in P is equal to 3. 1, 2, 3. The number of elements in Q is equal to 1, 2, 3. Therefore, number of elements is also same. The elements also same. Here also 5, here also 5, here also 6, here also 6. 7, here also 7. Therefore, these two sets are equal. Capital P is equal to capital Q. If the elements are different, take another example. Capital X is equal to small x, y, z. Capital Y is equal to A, B, C. Check if these two sets are equal. See, the number of elements same. 1, 2, 3. N of X is equal to 3. Number of elements in Y, 1, 2, 3. N of X, Y is equal to 3. But see the elements X, here not. Y, here also not. Z, here not present. Therefore, capital X is not equal to Y. What is the difference between equivalent system sets? What is the difference between equal sets and equivalent sets? The number of elements both are same, but in equal sets, all the elements exactly same. In the equivalent sets, that can be different. Therefore, this is equal set, this is equivalent set. Here you have one example. Or. What is the meaning for or? Say this statement is yes or no. Okay. Or A is equal to X such that X belongs to capital N. 4 less than or equal to X less than or equal to 8. And capital B is equal to 4, 5, 6, 7, 8 equal sets. First you write the given set. Capital A is equal to X such that X belongs to natural numbers. 4 less than or equal to small x less than or equal to 8. What is the meaning for natural numbers? The number starts from 1. What is the meaning for 4 less than x less than 8? It starts from 4, ends with 8. Therefore, the elements from 4 to 8. Therefore, the values are 4, 5, 6, 7, 8. Now, the set B is given directly 4, 5, 6, 7, 8. Now, first you count the numbers 1, 2, 3, 4, 5. Therefore, number of elements in A is 5. Count the elements in the set B, that is 1, 2, 3, 4, 5. Therefore, N of B is equal to 5. Now, you have to check the elements. Is the elements are exactly same. Exactly same. That is 4. Yes. 5. Correct. 6. Yes. Therefore, here the elements of A and B are exactly same. Therefore, capital A is equal to capital B. Next, universal set. A universal set is a set which contains all the elements of all the sets under consideration and is usually denoted by U. 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 See the example, if you like to discuss about natural numbers. What are the natural numbers? Starts from 1. 1, 2, 3, etc. When you are ready to discuss about the natural numbers, The natural numbers is the universal set. Universal set is denoted by capital U. If this is the universal set, inside you have all the numbers which are belongs to natural numbers. You can take many small sets, only 1, only 2 and 3, only 5. These are the sets belongs to natural numbers. Therefore, if you take the first set as A, second set as B, third set as C, the capital A belongs to the natural numbers. Therefore, capital A is a subset of capital U. If you are discuss about planets of solar system, take all the planets inside this set. That is the universal set. Planets of solar system. When you are discuss about Earth, that is a planet of solar system. Universal set means all the planets of the solar system.